on this computer. Okay. So you can access the recordings, right? The yesterday which I shared.
I haven't checked. I will check it today. Yeah, sorry,
Mm-hmm.
because I haven't got the laptop here. Left now.
Okay. Okay. So, okay, today we'll start with Git. So yesterday we discussed why do we need Git. So we'll cover more on that again and the requirement for version control. So version control is one of the most important part of any DevOps cycle, because whenever you are going for the interview, like I'll tell you how people are starting the DevOps interviews these days. So in the starting of the interview, they will tell you all the uh, that they will ask you all the questions based on different phases. They will start with Git, then they will come to build, then they will come to code analysis, then they will come to containers, then they will come to monitoring, then they will come to cloud, something like that. So for every stage, they will ask you questions. It's not like they will ask you for a particular tool, but they will ask you generic questions. And obviously you must have written various things in your resume regarding the tools which you have used. Then they might go a bit more specific on the particular tool. For example, if you have written Git, so they will ask you about Git. If you have written Mercurial, they will ask you about Mercurial. So something like that. Okay, so we'll today start with version control. Okay, so first of all, why do we need version control? So yesterday we discussed the issues that people were facing. Like before the version control came in, like before people realized version control is important, what was the issue they were facing? For example, when uh, there were multiple people in the team. For example, let's say 5 people were there in the team, and they were working on a project. Okay, and they had a code to write. So what did they do? And let's say all 4 people are working on the same block of code. Okay, they are working on the same file. Let's say. So what used to happen? So person A used to edit the code in his laptop, in his system. Laptops were not there around that time, I guess. So that person used to write that code into the file and save it somewhere in his laptop. Okay, then he would save it somewhere on the uh, in a common place, in a shared drive, let's say. Okay, another person would take the same file. He would write his things in his file and again save that in the common file. For example, you can assume NFS or any network file storage. He would save it. So, but it was very difficult to see the version, like which person changed what. So there used to be a manager. There used to be a person who used to manage all those files. Okay, let's say these guys are working on different set of files, and person A wrote some code and he pushed. Not don't talk about the word push, because push will be specific for Git. Okay, he will, what the person will do, he will write his code and he will copy that particular file the uh, to the file system, to the shared file system. Okay. So, similar way, multiple people will do the same. So at the end of the day, what will the manager do? The manager who's sitting at the who has access to the shared file system, he will go through all the code, all the files, and he will start merging. Okay, this person wrote this code, this person wrote this code. Okay, these are in the same line. There is a conflict. I need to merge them. I have to create a new file then. So he used to do everything manually, and also it was very difficult to track. Ultimately, there has to be a same file on the file system, right? So it was very difficult to track like which person did what change. And similarly, let's say there was a requirement that okay, this part of the code is not working, and the code which was written 3 days back, like 3 days back, that has to be bring into effect. What? So there was a lot of issues at that time. So got this problem? Hmm?
Yeah.
Okay, got the problem. So now we'll come to solution. What was the solution people thought about this problem? So they thought about version controlling the things. So there is something called source code management. Okay, source code means the code you are working on, the files you are working on. That is a source code which has all the code. Okay, and the process to manage it is called source code management. Very easy. And Version control is just managing the version of those codes. Okay, I have 10 files in my code, let's say. Okay, they are on version 1. I changed one file out of it. Now my code is on version 2. Okay, next day I change another file. My code is on version 3. And let's say I want to go back from version 3 to version 1. I can roll back. So I have all the tracking. I can track my changes. What are the changes I did in version 1? What are the changes that I did in version 2? What was the change? What are the changes I'm doing in version 3? I can track it. So this way, multiple people in the team can easily collaborate with each other. It's very easy if there is a single person. If there is a single person, it's fine, right? He knows that only he is the person who's working on it, and he can easily control. But if there are multiple people working on it with the version control and source code management, this thing became easier. Okay, so that is why version control and source code management came into picture. So this helped in collaboration. We had this versioning here. This was easy for rolling back. If version 2 fails, we can roll back to version 1. Okay, then it was good for understanding and tracking the changes as well. We can check like, okay, this was a change we did in this particular thing. So after a year, after 2-3 years, if we go back and check, yeah, 2-3 years before in this file, this change was done by this person, and he wrote a reason for this. Okay, this change was done because of this situation arised. Okay, so everything became easy to track. So that is why this version control and source code management came into picture. Okay, so this source code management was a solution to the problem which we discussed earlier. Okay, now there can be multiple types of source code management. So people came across multiple types of source code version control systems. Okay, so one is the two types are centralized and distributed.
Sorry, are you sharing any screen or just?
Sorry. Thanks for
I was
reminding.
wondering if you're just.
Thanks for reminding.
No.
Can you see my screen now?
Yeah, that's much better.
Yeah, so we discussed. Thanks for reminding. Sorry, okay, we discussed this slide only, just one slide we discussed. Okay, why do we need version control? Okay, so we discussed there are multiple developers and they used to copy the files into their a central repository somewhere. Okay, so we discussed the problem and the solution was the version control. Okay, and the why do we need version control? Because we need collaboration among the team. If there are more members in the team, then we need versioning. Then we need to roll back sometimes, and we need to track the changes, like who did what. So this was the reason that version control came into picture. Okay, then there are two types of source code management. Okay, there are two types of source code management process which we have, systems we have. Okay, one is centralized, then other is distributed. Okay, both are used. So you must have heard the word SVN. Okay, subversion controls. So as SVN, you must have heard the name. So SVN is an example of centralized version control, and you must have heard the word Git, and also that we'll discuss. That is an example of distributed version control. Okay, we'll see what is the difference between centralized and distributed version control. So coming to the first one, centralized version control. So as the name says, so I give you an example, right? Subversion SVN. SVN is subversion control. That is an example of centralized version control. There is something called CVS, Perforce example. These were the things that we have. So SVN is used these days somewhere, but these are not popular. These days popular are distributed version control. Okay, but we'll see centralized version control as well. Okay, so you see the diagram. So what is the central version control? Central server repository holds the official copy of the code. So there is something called a repository. So we discussed yesterday, right? There is something called repository. Repository is like a common file, common place where all the code will be there. Okay, that is a storage, you can say. That is a server which is storing all the files. So that is a repository. You can assume it like a storage. Okay. So in CVS, you have a central version control like a central repository where everything is stored. And then let's say you have multiple people. Okay, you have person working from workstation 1, person working from workstation 2, person working from workstation 3. So they will have their own working copy. Working copy as in they will copy their code from the main repository. Okay, and that will be their working copy. They will start changing their things, whatever they want to change. Okay, this guy will start working on his working copy. This guy will start working on his working copy. This guy will start working on his working copy. Okay, now after they are done with the changes, they will commit it to the main repo, to the central repository. Okay, so this is called commit. Commit means saving your changes to the central repository. That is called commit. Okay, then let's say next day they're coming up. They are coming to office next day and they want to start working again. So again they can update their code from the central repository. Okay, so that is called update. Updating means like taking all the changes from the central repository to your working copy. Okay, that means update. So here, so this is a version control, right? Here also what will happen, we can take an example. Okay, let's go through other points as well. So the server maintains the sole version history of the repo. So here what the server we have a central repository. All the versions of the repo, all the version of the code will be maintained on this server only. Okay, so let's say we have a file 1. Right now there is only single file here. Let's assume there is a single file in repository. Now server there is a single file. Okay, so here you can make checkout of it to your local repo. You make your local modifications, but your changes are not versioned. Okay, when you are done, you check in back to the server. You check in increment the repo version. Okay, so coming back to example. So we have this common repository, a server where everything is stored. Let's say right now there is a single file in it. Only one file is there. Okay, file1.txt, let's say. Okay, and let's say we have only one user right now. Okay, user A. What will user A do? Let's say user A has a task to change something in that file. Okay, what will he do? He will do a checkout of the file into his working copy, into his work area, in his workstation. He'll have a laptop, right? In his laptop, he will do a checkout. After the checkout, this file1.txt, this will get copied to his local copy, to his local system, to his local laptop. Now he made his change. Okay, now he made his change, and now he wants to save that change into the server, into the main server, into the main repository. So what he'll do, he'll do a commit. He will do a commit. Okay, now when he does a commit, the file which he modified gets updated on the server, and the file will get updated, and there will be a new it will be tracked with a commit ID. So that is what version control is, right? We are tracking the version. So how these versions are tracked? These are tracked with the commit IDs. So whenever someone commits, there will be a commit ID corresponding to the file. So he commits file1.txt, and there will be a commit. He added a line in that file1.txt. So there was a commit ID with respect to the change which he did. Okay. So next day, let's say next day, person 2 is coming. Okay, user B is coming, let's say. Okay, he also wants to update the same file. What he will do? He will again do a checkout. This is a new laptop. Okay, he has a different laptop. So he will check out that branch, like check out the file into his laptop. Okay, modify that file1.txt, whatever the other changes he wanted to do, and then again he will commit it. After committing, what will happen? After committing, those changes will be again sent to the main repo. Okay, the server, the main storage, that commit will happen, and it will again be with a different commit ID. Okay, let's say the same day another person comes in, user C comes in. He does the same. He creates a checkout of that file in his local laptop. Okay, and he edits something in the file and he commits it. Now there are 3 commits on this file. Okay, and now since this is a version control, so we can track it. We have 3 commit IDs corresponding to 3 different users. Now on these commit IDs we can check, okay, this commit has been made by this person and this was the thing he changed. This commit was made by user B and this was the thing he changed at this particular time. Okay, we can track everything here. Okay, so this way everything is version controlled. Okay, so now let's say on the 4th day, user A has to again work on file 1, but there is file 1 already in his local, right? He started working on it. File 1.txt is in his laptop, but it is not updated, right? It is not updated right now because he made the change. He created the file. He did some change on day 1, and after that, on the 2nd day, there were some changes made by user 2. There were some changes made by user 3 in the 3rd day. Now on the 4th day, he again wants to make some change. What he will do? He will update his file with the latest file. Okay, this is what update is. Update is bringing the latest changes from the from the this shared file system, like not file, don't call it file system, but from this repository to your local laptop. Okay, so now the file1.txt in his laptop will be updated with the latest code. Okay, now his file will have all the changes, the latest one, because the repository had the latest thing, right? The repository has the latest file1.txt, which is having all the changes for all the users. Now, when he did an update, the latest changes were brought in his laptop. Okay, now again he can make a change and commit. Okay, got it? Got this concept? Shah, Prakash, got this concept?
Yeah.
Clear, right? This is clear, right?
Yes, yes.
And
I mean, normally,
yeah.
Sorry. In situations where, like, these repositories is maintained by third party, right? So, like, we are saying GitHub or GitLab or
No, this is not GitHub. This is not. This is a software, you can say.
software is
This is
maintained
something
by us,
software.
like local to the site, not third party.
Not a third party. It is not third party.
Okay.
It is not third
Server,
party.
this is in the customer premise, isn't it?
Correct. It is not
Okay.
third party. We'll talk about third party later, but this is not third party.
Not third party. Okay. Can this be hosted in the normal? What is the best practice like this? I mean, they don't use this kind of system, isn't it? Do
No,
they use it?
people are not using centralized version control these days.
Yeah,
So I'll tell you the failure points here.
Yeah.
I'll tell you the failure points. So this is something at the remote. This is something at the remote.
Okay.
So sorry. By third party, what did you mean earlier?
Third party, like GitHub or GitLab, example, these providers who are hosting this.
Third party, yeah, you can assume it like you can assume it like that, but see, there are two things here. This is a working copy. Okay, this is a working copy on your laptop. Here you are not maintaining any version. Here you do not have any, you are not maintaining any versions here. All the versions and everything are maintained on this server, and this is something remote. You need internet to connect to it. Okay, it's not like you are working on the laptop and you're committing things, laptop, and you can track whatever changes you are doing. No, it is not possible. You are not maintaining the versions of that file into your laptop. Okay, on your laptop, if I say that, okay, file1.txt was in which version, I cannot track it. I cannot track it from my laptop. My laptop has to connect to this server to get the tracking, because if all the versions and everything are maintained on my server only, because this is my repository where everything is stored, right? This is here on the laptop. It's only my working copy. You can assume I'm working on a file. Okay, I'm working on a text document and uploading it to that repo. You can assume it like that. Okay, for that, Word file
Yeah.
on the txt file on my laptop, I cannot track the versions. Okay, this was
Yeah.
the version I was working today, and this was the version I was working tomorrow, working yesterday. So I cannot track all these things.
Mhm.
Tracking and everything happens on the server, because all the versions and everything are stored on this repository, on this server only.
Mhm.
Okay,
Okay.
this is a
Yeah.
remote server. This is a remote
Yeah.
server because many people are working on it. This can be person in Mumbai, this can be person in Singapore, this can be person in US. Okay, so everyone is working on the same repository.
Yeah.
Okay, but they are not having the versions on their laptop.
Mhm.
They are just copying it, taking in the checkout from the this repo and updating, doing the changes and pushing it and just committing it to the server.
Okay. And when they check in, and the server will update the version automatically.
Yes, yes, yes.
Okay.
Check-in means,
So like,
yeah.
can multiple person check out, or it's just one at a time?
No,
Or
multiple
it
persons can check
depends
out.
on the
Multiple persons can check out at the same time.
Yeah. Okay. All right.
Like multiple threads can work on it.
All
That
right.
will not be an issue. Multiple people can check out at the same time.
Oh, that's going to be difficult, right? Like, see, like if user one, the PC one does some update, then PC two does some update,
Mm-hmm.
and then if it is like dependent, like whatever the code update they have done, will that not affect the overall, the file, the executable execution?
Mm-hmm.
How do they track like that?
So you're talking about the conflicts. Like if user one commits of something in file one, and you at the same time user two also commits something in the file one. Uh, did I get your question right? Like if they commit on the same line, what will happen? Will it create
Because user one
conflicts?
updated the code, and it's now having different elements in the code, right?
Mm-hmm.
And now user two's code doesn't work properly because user one updated the code. I
Hmm.
mean, that's
Correct. That
how
will
do they?
happen.
Yeah, yeah,
That will happen because he needs to update his code again.
yeah.
He will have to
Okay.
update his code to the latest version if he wants something latest.
Hmm. So these are the fallbacks, is it? Like with this
No, these are not the
centralized.
fallbacks. These will be always there, because let's say if there are multiple people working in a company, if
Yeah.
and it's very highly likely that they will work on the same piece of code. Okay,
Okay.
and these things will come in. These
Yeah.
things will come in even this will come in even with distributed. These things will always come in because,
Okay.
and
All right.
again it will
Okay.
be there has to be some manual activity for sure, 100%. Merging, it
Okay.
can be like merging and everything that will be there. Let's say a person A is committing something in file one, he's storing it, he's committed that in the remote repo, he committed that in the this repository, and
Yeah.
person two also committed the same line of code and pushed it there, so there'll be conflict.
Mm. Okay.
So there has to be some, he has to merge it, like there has to be some merging happening.
Yeah.
Merging has to be done.
Hmm.
Okay,
Okay.
so we'll see that.
Okay.
So, but this was the concept of centralized repo. So we had a one single repository which was maintaining all the versions, and people had their working copies. And at the working copies, there was no version. But it was not version. Working copies were not versioned. You cannot track anything. So, what was the drawback of centralized version system? So it had a single point of failure, right? If the server goes down, what will happen? Everything is lost. You don't have anything if your server goes down. You cannot track anything if the server goes down. If something disaster happen, let's say, so everything goes down, right?
Yeah. I mean, normally don't they have backup servers like that nowadays?
They will have backup
With the,
servers. They will have
yeah.
backup servers, but
Mm.
it is a single point of failure, right? At this time, what will happen if there is a disaster happening on the server? It crashes. So all these versions are
Hmm.
lost for some time, right? People who are working there, and yeah, there will be another server. Let's say for this, there will be obviously some disaster recovery techniques they'll be having.
Yeah.
Okay, so that will be there, but this was a
Hmm.
drawback of it, right? Because
Hmm.
all the versions are stored here, and someone needs
Okay.
internet connection to connect to this repository.
Yeah.
Okay, so these were the drawbacks.
Okay.
So to address these drawbacks, people started thinking to use distributed version control system. So what is distributed version control system? So here also you have something called repository. That is a main repository where you have everything. But apart from that, you have something called local repository as well. Okay, you have something called local repository as well. So let's say you have again. So for this, there is a repository I told you, with the central repository where everything is stored. That is, versions are maintained there. But versions, there is also there is also concept of local repository. Local repository are local to the user. Okay, and these local repository also maintain the version. Okay, here also you can track the version of your code, whatever is it. So this saved us from disaster. Like if the disaster happens on this server, then at least we can track all the versions and do and continue with our work here on our local systems. And I do not need internet to connect to between working copy and this local repository. It's on my laptop only. I do not need an internet. Okay, but to connect from local to remote, yes, I'll need an internet. That is for sure. Okay, got the difference? I'll explain more on it, but but high level view was this. This is the difference. So in the central repository, what you can see, you have a working copy. There is no version control, nothing. The things are not versioned here. Okay, and this is a central repo. You need internet to connect to it. If this fails, everything goes down. But in distributed, apart from this, like you have the central repository here as well, but you have a local repository as well. And local repository is local to every user. This user A will have his own local repository. This user B has his own local repository. This user C has his own local repository. And from this local repository will be exact copy of the main repository. So this is also repository, right? This is also storing all the files and everything similar to this. But this is local to you. And you can create a working, and again, you will have a working copy. Working copy is the same concept like we have there in the centralized versioning system. So working copy concept is the same. We'll have a working copy. We'll have a file there. We'll update the file. We'll commit the file. Okay. If we when we commit the file, it will go to my local repository. And after I update the file, and again, if I do some change and then again I do a update, I can update my working copy with this local repository. So if a single person is working fine, then he can work on this repository only. If a single person is working, okay. But if let's say he wants the world to see his code, let's say in a system where multiple people are working, okay, in multiple people are working, so obviously multiple people will be working in a project. So what will happen in this case? He will have to push something to the central repo, to the remote repo. He has to push something so that others can also see what this guy has worked on. Okay, and others will have to update their local repo with the remote repo. Okay, we'll call this as local repo, and this main repo is remote repo. Okay, so the other people who are working on the project will have to pull the changes. We call it pull. Okay, we'll have to pull the changes from the remote repo to the local repo. Now this repo is also the latest. Now their local repo is also the latest. Okay, now they can bring the changes to their working copy. Okay, they can edit the file, they can commit it to the local file, and okay, and they can start working on it. And again, if they feel that okay, now my things are ready to be sent to the remote server, they can again push it. They can push the file to the remote server, to the remote repo. It will get updated. Got it? So I'll go through this slide again. So if you have any doubt, let me know. Okay. So in Git, Mercurial, etc. are the example of distributed version control system. Okay. You don't check out from the central repo. There we had the word called checkout. We used to call it checkout something. But here we clone it. Okay, we clone or pull. We pull the changes. We call it pull. Pulling the changes from the remote repo to the local repo. We call it something like this. Okay. Your local repo is complete copy of everything in the remote server. It's exactly the same, because this is a remote repo, this is my local repo. It is, both the repos are in sync initially, so it is almost the same. It's like there might be some changes with what others are pushing, but you can always pull those changes to your remote to your local repo. Then again, it will be in the same state. Okay, many operations are local.
The local
Okay.
repo, just
Hmm?
confusion. So local repo
Mhm.
is it a server in the
No,
local?
that is not a server. That is your local laptop. Let's say it's your
It's just
laptop.
in a laptop itself. Okay.
Yes, it's in the
It's
laptop
like
itself.
okay.
It's in the
Like a
laptop
function
itself.
in the laptop. Okay. I mean in the software,
Hmm.
which and so that actually clones everything that's in the server, right? Clones
Correct.
all the yeah, okay. And it
Correct.
stores in the laptop, and then from the laptop, whatever I'm updating, it just updates, right? Like that, isn't it?
Yeah, that is
And
pushing.
in this,
Pushing to it.
okay,
Mhm.
okay, and this manual push and pull, right? Not automatic, isn't it?
Yes, it's manual. It's manual.
Okay,
There are ways to automate it as well, but
okay.
everything can be automated, right? You can write scripts
Yeah.
and automate it. But yeah, we do
Yeah,
it
like
manually.
what I'm saying is like if someone like user 2 updates it, does it automatically update in my local repo that there's an update coming from server?
Okay, you are saying if user A updates something on the remote repo,
Yeah.
so there can be automated update on user B's repo also get updated.
Yeah,
Something
yeah,
like
something
this.
like that. Yeah.
Yes, this is possible. This is possible.
Okay.
You can always write a cron job or things that are running continuously and
Okay,
pulling the
so you
changes,
just
and
right. Okay.
automation can be done. Automation can be done.
Mm-hmm.
Hmm.
Okay,
So
fine.
many operations are local. Local operations mean check in, check out from the local repo. Okay, so there is a local repo. You always can check in and check out, like from the working copy. So here also versioning is maintained, right? In
Mm-hmm.
CVS, in central version control system, what used to happen? Their versioning used to happen on this repo only, on the
Mm-hmm.
main repo only. But in distributed, versioning happens on this local repo as well. It happens on there as well, and here as well it happens. So on your local machine also you can check, you can maintain the versioning. Okay, let's say you're working on file1.txt, for example, I said. Okay, what will happen? I'll walk through again the same example, similar kind of example in this context. Okay, so there is something. Let's say there is something in the uh, main repo right now. Okay, in my remote repo there is a file1.txt, and there is a user one coming on day one. What he will do? He will pull the changes to his he will create a local repo. First of all, he has to create something, right? He has to install this software on his laptop. So he has to install a software in that on his laptop, and he has to link his remote repo to this repo. Okay, that he has to do to sync, just to create a hook between a remote and local, right? He has to do. So what he will do? He install something. He will initiate that connection, and he will do a pull. When he pulls, so whatever is there in the remote repo, that comes to him in his local repo. Okay, now in the local repo, what he will do, he want now this file1.txt what he had, it comes in his local repo now. Okay, now what he will do? Now he will do a checkout, like similar to what we were doing here. Here also you were doing a checkout, right? We were doing a checkout of that file1.txt in my working copy. I was changing, user was one was changing it and committing it. Here also he will do the same. Now the file1.txt is sitting in his local repo only. So he will, from his working copy, he will do a checkout of this file 1.txt. Okay, he will commit it, like he'll make the changes and commit it, and after he commits, that changes will be sent to his local repo only. Okay, that changes will not be sent to the remote repo. That changes will be sent to his local repo only. Okay, now again he wants to change something. Now let's say version 1 is updated on his local repo. Okay, now let's say tomorrow he comes, tomorrow again he makes a change in this file and he commits it. Now version 2 is updated in his local repo. See, versioning is happening on his local repo also now. Now instead of again using internet to go to this server, to the main repo, what he can do, he can do it on his local only. He does not need internet now. working copy in repository is there on his local system only. He can just, whenever he wants, he can start working on that file and commit it. And that commit will be reflected as a commit ID on his local repo. Okay. So similarly, next day, let's say another person comes in. Okay. He also does the same thing. Okay. So there is something file1.txt, but this file1.txt does not have the things which user one has changed, because user one has changed and committed the things in his repo only. Got it? He has not pushed his changes to the remote repo right now. Okay. So all the changes that user one has done is committed in his laptop only. Okay. Now the user two comes in, he pulls that file1.txt in his local repo. What will he see? He will not see the changes done by user one, because user one has not pushed the changes to the remote. User B will see the old file that was there, like the file which is in the this main this remote server right now. He'll get that file. Okay, and he'll also start working on it the same way user one was working. Okay, now let's say this person, user B, commits something, makes changes to the file, he commits something, and he saves, and that particular file is saved, is committed in his local repo. Okay, in his local repo. Now he pushes that change into the remote repo, let's say. Okay, this file1.txt now will have the changes which were done by user B. Okay, but user A still is working on his remote repo only. User A is still working on his local repo only. Okay, and he still has the old changes that he had done on the old file. Okay, now what he will do? He will pull the changes. So what pull thing will do? Pull will bring the latest changes to his remote repo, to his local repo. Okay, that file1.txt will be, if we do a pull, that file1.txt will be updated by the latest changes that user 2 had pushed. Okay, so that is called pull. So now again he can add something and work on it on the new file. Okay, then again he can work on it, and then he can commit. He can commit in the local repo. Now he wants that, okay, I'm done with my changes. I want to push all my files to the remote server. Now he'll push that file1.txt to here, and this file1.txt in the remote server will now be the latest one, having user one changes, user two changes. Okay, and again that user one changes on the top of it. Okay, got it? Got the concept?
Yeah.
And so here, what happens if this, let's say, server goes down? If your internet is not working, let's say, or your server main repo goes down, what will happen? It is not a big impact, right? It is not a big impact, because everyone is having their local repo. They are maintaining their versions, and they are maintaining their all the codes and version source code management, everything they are doing on their local repo only. Okay, there will be impact for sure, but impact will be lesser as compared to central version control. Got it? Any doubts on this distributed version control system?
Okay.
So you will get this concept more, because this we are going to cover in detail. So you will see everything here. You will see many things here, even more than much more than that.
Yeah.
Okay, but this was just the basic. Okay, this was just the basic. I'll show you in the demo as well how things are working, but this was just the basic. Got it?
Yeah.
So here, when in case of subversion, what used to happen? Subversion means that central version control system, I mean. Okay, so what used to happen? If you change, let's say you have version 1. Okay, assume like in version 1, you have file A, file B, file C. In version 2, you changed something in file A. Okay, and you did not change anything in file B, and you changed something in file C. Okay, so this particular version 2 will not have file B. File B will still be in the same initial version. Okay. It is very clear from the diagram as well. Okay, in subversion 3, let's say you are in version 4. So version 4, see, on version 4 also, you see that file B is on version 1. Okay.
Yeah.
Centralized version control, like subversion, tracks version data on each individual file. Okay, it is tracking version on each individual file. But Git keeps a snapshot of the entire state of the project. So see here, difference here. It is keeping the track of the whole snapshot. So here in this version 2, in this version 2, we did not change anything in the file B, but still it keeps a track. It keeps a track of the entire it is the snapshot, what we call it. It has the entire state of that project. Each check-in version of the overall code has a copy of each file in it. Okay, when you do a check-in, okay, it will have everything.
Yeah, it's cloning everything, right? Our local drive.
Your voice is not clear.
Well, I'm saying like from Git, we are cloning everything, right? All the files.
Yes, when we do a clone and we do a check-in, the whole thing is getting cloned. Each check-in version of the overall code has a copy of each file in it. If you do a check-in of the version 2, if you do a check-in of version 3, then all the files will be there in it. Okay. But if we do if we do check-in of the version 2, only the files that were changed will come in. Okay. But here it's like storing. You have worked on AWS, right? You know how the snapshot works.
Yeah.
Correct. Snapshot is an incremental, right? You know that snapshots are incremental.
Yeah.
So what happens in that case? Let's say you have a file you have a 2 GB file. Okay, you have a 2 GB file. Next day you come, you you create a snapshot. You create a snapshot for 2 GB. That snapshot will be of size 2 GB. Okay, then next day you edit something. You add, let's say 100 MB. Let's say you add 0.5 GB. You add 0.5 GB of files in that thing and again create a snapshot. So what will happen? A new snapshot will be created and the size of the snapshot will be 0.5 GB. It will not be 2.5 GB because it is incremental, right? So here it saves the space. Instead of creating an entire new snapshot of 2.5 GB, so what would have happened? It would have initially we had 2 GB and now we will have another snapshot of 2.5 GB. But it does not happen like that. It will be incremental. The new snapshot that we'll have that will have the new files. Only it will have the new files, and it will for the old files it will refer to the old snapshot. So that's what happened, right? So Git does the same. Okay, it works on this only.
Yeah.
Okay. Now you must have heard the term Git and GitHub. Okay. So people sometimes confuse between these two things. Like they say that okay, Git and GitHub are the same. It's not like that. Git and GitHub are not the same. Git is a software which runs on a local repo, something like, you can assume it like that. What we are discussing here, the local repo and working copy. So Git acts here only. Okay, Git acts on this only, and the server where you are doing it, this is actually GitHub. Okay, this is the GitHub. This is the main repo where everything is stored. Okay, that is GitHub. So that is the difference. Okay, so Git is installed and maintained on a local system rather than in cloud. Okay, so whatever you have the local repo in the cloud, a local repo in your laptop, so that is Git. That you can assume that is Git. It was developed in 2005, so it is pretty old. It's not a new thing. Git is pretty old. So that really sets Git apart. It is branching model. So branching model we'll study, and then maybe today after a demo, if we'll see if we have time, then we'll study branches as well, or we'll do it next Saturday. Okay. Git is a high quality version control system, and it is like the person who created Linux, that the same person created Git also. So it is like so mostly all the commands and everything you will find it like something similar. Like you will see those commands, you will relate a lot of the things there. Okay, but what is GitHub? GitHub is designed as a Git repository hosting service. Okay, Git repository hosting service, that is, it stores all the code. It is a central repository, okay, where you store everything. So GitHub is exclusively cloud based. Okay, so whatever you store is stored somewhere remote. Okay, there might be some remote storage where the things are being stored, all the branches and all the code is being stored. You can share your code with others, giving them the power to make revisions on edits. So we saw that, right? So
Yeah.
this will come into picture when multiple people are working. If a single person is working, then we don't need this, right? We have Git installed on a laptop, and we can just write a code and just commit it, pull it, push it. What means commit it, commit it, update it, and nothing happens. Like it will not since we do not have any other person who requires our changes or whose changes we require, so we don't need it. So GitHub comes into picture when we have multiple people are working on a project, and everyone does his change, uploads on the remote, other person takes the changes from the remote and start working on the same. So that is where GitHub comes in. Okay, so GitHub is cloud-based hosting service. It's a hosting service. So GitHub is like GitHub was earlier, it was a freeware, but it was free. It was free earlier. Then Microsoft bought it. Okay, and then people started thinking like, okay, now Microsoft brought it and bought this GitHub, and now they will start controlling it and these things. So they started working on something again open source. So they now GitLab is also popular. GitLab is similar to GitHub, but GitLab is open source. GitHub is owned by Microsoft and it is not free. Like most of the things are free, but there are few things paid as well here. Many services in GitHub are paid, but GitLab is free. Okay, but they do the same thing. They do the same thing. Okay, got the concept? Got the difference between Git and GitLab? GitHub and GitLab, GitHub. You got the difference?
Yeah.
Okay.
Is there any meaning for Git? I never found it. Or
Hmm?
is it just is there any meaning to Git? Like, is it an acronym or?
Meaning of Git?
Yeah.
Yeah, they have the meanings. Initially, when they coined the word, I think they had the meaning. Let me search what is the meaning of Git. They had the meaning.
I never bothered to check
It
it.
says Git. The meaning of Git, as per dictionary, is an unpleasant person, something like that. That mean old Git, an unpleasant or contemptible person. Yeah, they name it like that only.
Okay.
Okay. So any questions till now?
No.
It's getting clear, right? Version control,
Yeah.
Git, GitHub, centralized version control, distributed. Okay.
Yeah.
Now, when we are talking about Git, so what happens? You guys want break? We'll start with the demo now. Okay.
No, I'm okay.
Okay. Just give me a second. Some water. So we'll see how everything is working now. Okay, we'll first talk about the local Git, like as in our laptop, how we see it. Okay, so when we okay, let me think how I show you. Should I show you with the demo itself, or okay, I'll show you with the demo itself. It will be more clear if we do it parallelly. Okay, so here what I'll be using, I'll be using 2 servers on my AWS account. You have an AWS account, right?
Yeah, the free account.
So I'll show you how I'm doing. Okay, I have to share these 2 screens now. New share. Okay. So let me know which screen you are seeing right now. Are you seeing my AWS console?
Yeah.
Okay. So for the demo, what I'll do, I'll launch 2 instances. 2 normal instances. I'll not do very fancy thing here. I'll just add do something, use a free tier. I'm assuming you guys know how to launch an instance and these things, so I'm straight away launching it. Okay, that is fine. I can launch it, right? Do I need to tell you all the steps here?
No, we know it.
That is fine, right? Okay. Okay, so I'll go with the default, everything default. I'll not change anything. Add storage, add tags. Okay, add tag, just I'll name it, let's say, server 1, just for giving it a name. Configure security groups. I'll add a existing security group. I had a security group which is like, you can create a security group which is allowing 80 HTTP 80 and SSH 22. That should be fine. Traffic from anywhere. Okay. Launch. I'll select a key pair. Okay, launch. Okay, I'll do another thing now. And I launch another EC2 instance. I'm just simulating the system situation where 2 people are working on the same project. Okay. Another system. So you can go ahead and create 2 instances in different region, but again that will be the same, nothing different. Storage. Name. Let's call it server 2. Okay. So my 2 instances are started now, almost started. Let's log into one of the server. I'll use putty. Okay, so this is my server 1 for, let's say, user A. This is my user A, server 1. Okay. So this guy has to work on something, let's say, has to work on some project. Okay, what he will do? He logs into a system. Now he wants to install Git. Git is a package that you can install here. So first let me update. I'll do a root. I'll become a root so that things are easy.
I don't see anything in your screen. I mean, only I'm seeing the.
Sorry. Wait, I'll
main.
share. Now I'm on putty actually.
Okay.
Now can you see my putty?
Yes.
Is it
So
fine
now
now?
you're logged into the user one, right? Or the server?
Yeah, yes. I logged into server one, which I created.
Okay.
Okay, this is my server one.
Yeah.
Okay, so I'll become a root. I'll switch to root user. I'll do everything as a root user. Okay. So here, let's say I want to work on a project. So what will I do here? I'll first let me update my okay, it should be updated, I guess. Okay, let's so let's install Git now. Yum install Git -y. Okay, so Git is a software. It's an open source. You can install it. Okay, so when I install Git, see right now I'm in my home directory of the root. Okay, what will happen here? Okay, let me tell you the concepts here. Okay, I'll can you see my other screen? Can you see my this screen? Do you see right now?
Yeah. Is it the console, right?
Okay, fine. Now it's fine then. Okay, let me explain you the concept of what happens here. I'll do a paint. Okay. Okay, let's say this is my laptop, local laptop. Okay. This is my EC2 instance. Okay. Okay. And inside this, I created a directory. Okay, I installed Git and I created a directory. Let's say this is my directory. Let's say I name it. What should I name it? Let's name it dir1. Okay, this is my directory here. So when I install Git I showed you how to install. You can do yum install Git -y. -y, no, it's for yes, means you don't have to give permissions afterwards. It will automatically install. So that was a command you can use. Git install, sorry, yum install Git -y. So that will install Git on the system. And then let's say I'm creating a directory. So first thing I have to do is I have to do git init. Okay, I have to do something called git init. So when I do git init, what will happen? I'll write the commands here as well. Okay, when I type git init inside any directory, so I wrote git init inside my directory which I created. Okay, and wherever I write this git init, that particular thing will start acting as my repository. Manage. Okay, I wrote git init inside this directory. I wrote this command git init. Now my directory one will start behaving as my repository. Okay, so let's try that as well. You can say a putty.
Yes.
You can say a putty.
Yeah.
Okay, let's create a directory mkdir. Okay, let's call it dir1. Let's go inside this directory. Okay, I'm in my dir1 right now. And what I'll do git init. So see what happens. It says initialized empty git repository in root dir1.git. And if I try to do ls-latr, means try to see the hidden file, you see that there is a .git file automatically created. Now this particular repo, means this particular directory, has starting to behave like a git repo, is starting to behave as my local repo. Okay, now here I can run all the git commands. Okay, here I can run all the git commands. I can do git ---- version. So it is giving me the version, git version this. Okay. Or I can do other things as well. Whatever commands I want to, git commands I want to run, I can run here. Anyways, git version I could have run without outside this as well. But yeah, whenever you have to run git commands, you have to come inside directory because this is now version controlled. Okay. So here what we will do? Yeah, so this is now your local repository that got created. Okay. And there is, you can type which git. This will give you the path. What is the repo? So it is giving me like where did the git got installed? We installed git earlier, right?
Yeah.
It got installed a user bin git. It gave you the place where git got installed. Okay. Then there are two things you have to do. You have to configure. You have to configure your name. So what happens? What was the why do we use distributed versioning control? Because we want to make sure, we want to keep a track of everything, right? Keeping a track also means that what person is doing what. Okay, if I'm trying to make a commit, if I'm trying to push the commit into the remote, on the remote someone can see that okay, this was the commit that was made by this guy at this particular time. Okay, everything should keep a track. So there are two variables that we need to set. So there is something called git config -- global username, and then you have to give your username. Okay, git config -- global. These are global variables. Okay, user dot name, and here you can provide your name. Let's say I write my name here. Okay, and again you can set the email as well. For example, you can send email as in some advanced use cases. You can send your email from here as well. So here you can mention your email. When your email will be sent, then also it will be sent using this email ID. So you can type anything here. It's not required. So we're just configuring whatever you want. .xyz or whatever at the rate random, nothing important. Okay. It's just setting the name. So if you do list, it will show you the things that you entered. Okay. Git config list. So it is showing you everything. So name was this, email ID I said this, then these are some advanced. The file mode is true and bare false. These are some advanced things that will show you. But these are two things which we configured. Okay, name and email, just to keep a track of where we are right now. Okay, then what we'll do. So these we can do only just after installing of Git. We don't need to do a Git init to do these things. Okay, these all the commands which I told you just now, git version and which git and git config, git list, git config, these you can do without doing an init. Init you can do later on if you want, because init what will init do? Init will turn the directory you are in into a local repository. Git init will do that. So now let's create something here. Let's create a file here. Okay, I'll create a file vi file, let's say file1.txt. Let's create a file here and I'll name it hello from server 1. Okay, so the change this particular guy did in this file, he created a file. So If I see this file, it is present here. So I created this file. So what happens when I do git init? I told you the directory becomes a local repository, and as soon as it becomes a local repository, there are 3 sections created on it. Okay, so coming to here, so this is my directory. It gets divided into 3 sections. One is my working copy. Working directory. Then one is my staging area. This you call as staging area. Okay, then here is my actual local repo. So this thing happens as soon as you write git init. When you run this command git init, so this happens. How can I move this upwards? Okay, so whatever file I'm creating, okay, that is happening in my working directory. So I created this file. I created this file1.txt. It got created in my working directory. So what do I want to do? I want to commit it. Let's say I want to commit it, but I cannot commit from working directory directly to the local repo. I cannot do that. I have to go through a staging area. Okay, staging area is what? Staging area is a place. It is a transition place, you can say. Let's say you have 100 files here. Let's say you create 100 files here, and out of those 100 files, you want to commit only 3 files. Okay, so you will move those 3 files into the staging area, and then you can commit it to the local repo. Okay, there is a command called git status, which will show you the status of your files. Okay, let's say I do a git status. See, what is the thing I'm getting? I'm getting on branch master. So master is my default branch. So when I did git init, what are the things it did? It divided this directory into three parts. Like logic, it's not physical division, it's a logical division. So one is your working directory, one is your staging area, and other thing is your local repo. Okay. And when you check this, when you do this git status, it will give you the status of the files, like all the files in your repo, like all the files that are either untracked or they are in staging area. Whatever is the status of the file, it will give you. For example, I created a file, file1.txt. So here it says untracked file. That is untracked because Git does not know it right now. Okay, Git does not know it right now. So that is why it is seen in red. Okay, it is shown in red because the file which we created, that got created in the working directory, and my Git does not recognize it right now. I have to add it. When I add it, it goes into staging area. Okay, let's say I added git add the name of the file. Okay, so this is the command. Git add is the name of the command. So now if I check git status, it is showing something in green. It's saying still on the branch. It is still in the branch master because master is the default branch. Branching thing we'll cover later. Okay, just assume that we are on the default branch. We are working on the default branch right now. That branch is a master. Okay, so it says no commits yet, since we have not made any commit, but the changes to be committed. Earlier it was showing untracked files because Git did not knew what files were there. The file 1.txt was unknown to the Git because we just created it, right? So we did a Git add. We did Git add file 1.txt just to make sure that the Git knows this file now. And when I did Git add file, it went into my staging area. And now it says new file, file1.txt. Okay, now it is in my staging area. And now from the staging area, if I commit it, it will go to my local repository. So let's do a commit. So the command is git commit, name of the file, and a message. Messages, it can be a tag or it can be it keeps a track of what, like they can be, it is just like a comment. It's a comment, like for what reason you are making a change. It can be text or whatever. You can write first commit, something like this. It just contains, you can write whatever you want. Like you can, like if this change is related to a particular development, so you can mention what are the feature this commit contains, or what if it was a bug fix, you can write what was a bug that was fixed with this commit. Okay, that you can write. Okay, so the commit is git commit, name of the file, -m, that means message, and that particular thing, that whatever you want to write. So see, it says master, because we were in the master branch right now. Okay, master and first commit, and it gives the commit ID. See, this is E2F. This is 20, I guess this is a 20-digit commit ID which it gives you. It's mentioning just first 6 letters for it. Okay, it says one file changed, one insertion, and that is plus. It means we added one thing, and plus things, that means we added. Okay, then create mode 10064, that is the permission it is saying, and file1.txt, that is the name of the file. Okay, so your file got committed to the local repo. Now let's see what is the status. So on status it says on branch master, nothing to commit, working tree clean. So right now there is no things which are unstaged. Like there is no things which are none of the file which is untracked, or there is no file that is in my staged area. Okay, on these two places there are nothing. So git status is not showing anything. It is just saying on which branch you are right now. And by default, as I told you, when you do a git init, so by default we are on the master branch. The branch we are in is the master branch. Okay, now my file got committed to my local repo. So I want to see the log. I want to check the log. What was the commit did I do? Okay, so as I told you that in the distributed version control, what you can do, you can track your versions on your local system only, on your local repo only. So let's check the log. The command is git log. Okay, git log, it will give you the full thing. It will give you a detailed thing. But if you want to just see a single line, you can type git log -- one line. It will give you a single line. That's it. Okay. See, this is the commit. This is the commit ID. You can see my screen, right?
Yeah.
Okay. This is the commit ID, and head means what is at the top. Head is at the top, right? Head is at the master branch right now. Like my control. Where is my control right now? That is the master branch, and it says first commit. That was the comment which I put, right? See, this was the comment which I put in this. So it gives me a detail of the commit ID and the comment which I put. So if I try to use git log without one line, it will give you something more detailed. See, it is giving you more detail. It gives you author as well. Okay, the author is Puneet, the one which we created earlier, the name using that git config. We created a name and an email ID, right? So it says Puneet and the email ID as well. My email ID is also given. And the date when it was committed, okay, and the name, like in the comment, what was the comment, what was the tag, or what was the reason for this commit, it is giving it. Okay, so you can see the log. And what if I want to see what is inside this commit? So what I'll do git show and this commit ID. So see, I did a git show commit ID. It is giving me the commit ID, the author, everything it is giving, date, that tag, okay, then the message, not a tag, the message. Then it is giving you diff. We'll see diff what it is. It is giving the difference between the initial version and the final version. Okay, it is showing new file because it's for new file. Okay, and see, earlier it was nothing, so it is giving /dev/null. Earlier it was nothing. Now what we added file1.txt, and what is the content? It says plus because we added this content. Hello from server 1. We added it. Okay, now it is showing here. Got it? Got these commands? I'll show you again. Okay, let's say I want to add another file now, or I want to change anything in this file. In this file, I want to do any change. Okay, what I'll do? I have this file here. I'll just now my file. This file is version controlled, right? Because I'm doing everything in my. I have added this file to my Git. I did a Git add, so this file is under version control now. So whatever changes I do here on this file, this will be tracked. Okay, I'll do change to this file. Okay, file1.txt. Let's say I add here new line. Okay, and I save it. Okay, now I see I do a git status. What is it showing? It is showing modified. See, it is showing modified, right? Because this particular file is tracked by Git right now. Whatever changes I do, it will be tracked. And if I do git status, it is showing me that this file has been modified. So now what should I do? I have to commit this file. What will I do before committing? Before committing, I have to move it to the staging area, right? To this area, I have to move it to the staging area. From right now, it is in working directory, whatever changes I have made. So I have to move these changes from the working directory to the staging area. So what will I do? I'll again do git add name of the file .txt. And again, I do git status. So see, it is showing green. And now it is saying the changes to be committed in this file again. It was showing changes not staged for commit. Okay, it showed changes not staged for commit. So I did git add, that is I moved to the staging area, move this file to the staging area, and now it is saying changes to be committed. Now I can commit this. Okay, now I can commit this. Again, I can do git commit name of the file and the message. I can put second commit. Okay, see again, it says one file changed, one insertion. Okay, now if I check the git status again, it is showing nothing because the file have already committed to the master, right? And git status will show only those files which are untracked or which are in the staging area, like untracked as in the working directory and in the staging area. The files which have already been committed, git status will not show that because these are those have moved to the repo, right? So what I'll do now, let's check the log. I'll do a git log. So git log is now showing 2 commits. My earlier commit was at 9:46. Okay, author was this, and the message that I had put was first commit. Now I did another commit at 9:53. Okay, and this was my second commit. See, and this is having a different commit ID. I want to see what are the changes in this commit ID. Let's say, okay, let's see what are the changes in this commit ID. I'll do git show and this commit ID. It is showing a this that I added new line here. So earlier, initially there was a single line called hello from server 1, but I added text called new line, and see it is in green and it is showing plus. That means this line was added by me. Okay, and this is a message using which I added. Okay, got it? Got it? This is fine, right? Because this was important, because if you have any doubts on this, it will be very difficult to understand the later things.
This is at the moment we are testing on the local.
I cannot hear you properly.
We are testing on the local system, isn't it?
Yes, we are testing on the local. We are testing on the local. We have not moved anything on the remote. We have not even set a remote repository right now. I'll show you how to set it up, but we have not even set it up.
Yeah.
Because I'm a single user here. I can create n number of files, n number of projects here. I can start working on it, do version controlling. So I don't care how many users are there, because it's my single laptop. I can work on it because I know that I can do anything, and I can track my files. I can do whatever I want with these files.
Yeah.
Okay. And let's say there is another user B in some other region or any other on any other laptop. He also wants to use these files. In that case, we have to use GitHub. Okay, we'll come to that. But this part is clear. Whatever things I want to do the local, git log, git commit, git like staging area, and local repo.
Yeah.
This is clear, right? Okay. So now let's say I have to move this to GitHub so that other user can also use. So what will I do? I'll create a GitHub account first. Okay. You guys go and create a GitHub account. It's very easy. Like it's a normal thing that you can do. So when you create a GitHub, I'm relying it on you that you will create a GitHub account. It's very straightforward. Just go and sign up. That's it. It will create an account for you. Okay. So on GitHub account, what you can see, you will see your profile there. In the profile, you will see all the repositories. Okay, you will see various repositories. Repositories are what? Repositories are where your files are getting stored, right? They can be your projects, they can be whatever you want. They can be your projects and whatever you want. So you will create a repository here. Okay. So you can create it, right? You can create a GitHub account, right? I'm relying on you that you will create a GitHub account. After creating a GitHub account, you have to create a repository. Okay, after creating a GitHub account that you will create, that is pretty easy. That's a normal UI thing. Then you have to create a repository. How do you create a repository? In this, you will see your repositories. You have to go to repositories. For now, I have already created 3, but I have to create a new, let's say, for this demo. Okay, I'll go to new. Okay, I'll create a new repository. Okay, I can name it August demo, something like this. Okay, description I gave repo for August, anything, whatever. Let's keep it public repo for now. You can keep it private as well, no issues. Okay, initialize this repo with add a readme file. That is fine, that you want or not, that depends on you. I'll create by default. Okay, this will create my new repository. So this is my repository. You will see it here. Then my name slash the name of my repository, and whether it is public or it is private, it will show. And there it will show you all the code, whatever is there. These are all the instructions that is giving you for now. But every repository will have a URL. Okay, see, HTTPS, GitHub, this is unique to my repository. Okay, if I have 10 repository, I'll have 10 different URLs. Okay, so this repository is unique to your repository. See, it's saying github.com, my name / August demo. August demo is my name of a repository. So we'll see how to clone this and these things later. But yeah, for this is your URL of the repository. So now this repository, you have to link it with your local repository. Correct. In order to push the changes to this repository, you have to link this repository to your local repository. Got it? Any doubts?
No.
Prakash, Shah, any doubt?
Sorry. Sorry. Thing is that I'm on holidays. I'll go through those videos and come back to you later. Is that okay?
Yeah, you are dropping, you mean?
Yeah. I will come back to you later next week. I'll go through the videos once again. Yeah.
Okay, so these videos are already in recording, so you can have a look whenever you want. Okay. Prakash, are you there? This was Prakash or this was Shah?
Hello.
Hello?
Hello. Can you hear me?
Your voice is not very clear, Prakash. Hello? Hello?
I can hear you. This is Shah, but I'm not sure about Prakash. I think his connection might be a bit low.
Prakash, can you hear me? Hello?
Hello. Can you hear me now?
Prakash, your voice is not clear. I guess there is some issue with your mic or. You are connected, I see, but I cannot hear your. Okay, did you paste something in the chat? Okay, it's clear. Okay, fine. So Shah, for you as well, like I'm recording this session, I'll paste the recording there.
Yeah.
Anytime go and watch it again.
Yeah.
So
I'll
all
come
things
back to you.
Okay. So here what will happen? This is my URL unique to my repo. I have created this repository, August demo, and this URL I have got. So what will I do? I will link my local repo to this remote repo because I want to push the changes from my local repo to my remote repo, right? So that other users can also see. Other people can also see the changes. So for now in the remote repo, what I see, I do not have anything here. If I go here, I'll not have anything. These are just the setup things they have given us, but I'll not have any projects or anything. I don't have anything here. Okay. So I'll have to link my local repo with this. So how will I do that? There is a this command git remote add origin. I'll paste it. So you have to run this command git remote add origin and name of your repo, like URL of your repo. Okay. Now it got added. So now what you will do? So what is this? Origin corresponds to my remote repo. What is my remote repo? This. What I'm doing git remote add origin. So I'm adding this to remote repo. What is my remote repo? This. I'm creating a connection between my local repo and remote repo. This is how I do it. Now what I have to do? I have to push the changes from my master branch. Like this, I told you, right? The default branch what we are working on is the master branch. So what I have to do? I have to push the changes that I did in the master to the remote repo. So how will I do? There is a command for this. The command is git push -u origin master. So git push. Push is we are pushing the changes from our local repo to the origin. Origin is what? Origin is my remote repo. And on which branch? Master. Because all the repos by default will have the master branch only. My local repo is also having the master branch which I was creating, which I was using, and same with the remote repo. Remote repo will also have the master branch. So what I have to do is git push -u origin. So I'm pushing all the changes from my master branch to from my local master to origin master. Okay, so this command means this. So if I press this, so it will give me, it will ask for a username. Username is the username of your GitHub account. So using which username you might have created. For me, it's my email address. Okay, I put my email address. So it is just linking. It is just trying to link my local repository to my GitHub account. Okay, so how will it do? It will ask for the username and password, right? So I put my username and now it is asking for password. The password earlier, what used to happen is before 2001, what used to happen? The normal password that you have for GitHub account that is to work, but now it does not work. Now what you have to do is they have started a concept called PAT, like personalized access tokens. So these are tokens that you have to generate, okay, and that you have to use as a password. So how to generate it? I'll show you. So go to your GitHub account. Okay, go to your GitHub account. Go to your profile. Here, if you go to settings, okay, go to settings, and then at the bottom you see developer settings. Okay, in the developer settings you have something called personal access tokens. Click on that. Okay, click on that, and you can generate a new token. For me, I have already generated one, so it is saying revoke all or generate new token. These options I'm getting. For you, since you have not generated any token, you will by default get this option of generating a new token. So we can generate a new token. Let's generate a new token now. I can give this token a name. So let's say I name it like August, whatever. It can be any name. It's just for random thing. And expiration and how many days your token will expire. Token is nothing but a password. It's a kind of password only. Okay, then you can select the scope. Like let's select everything for now, because it's like what are the permissions that you are trying to give. For example, you must have seen in AWS IAM, right? We select all the actions for which we give all the permissions. So this is something like this. So I'll select all for now. We might not be using everything, but yeah, we can choose all. So my pat, wherever I put my pat, that pat will have all the rights. Just select everything. No need to think a lot on it. Okay. So what I'll do, I'll generate token. So my token got generated. This is my token. Okay. And the thing is, you have to keep a track of this token. Don't miss it. Just copy it at a safe place somewhere. Okay. So if you close this page, the token you're not able to find this token again. Then you again have to generate it, and generation is fine, you can do, but just keep it a note. Keep this pat as a note somewhere. Okay. Save it somewhere safe. Okay. And where it was asking for the password, just use this token. Okay. It is hidden, so it will, even if you paste it, it will not show here. Just after pasting, press enter and see. It is saying enumerating objects 6 done, counting objects 100%, then compressing objects whatever it is giving all the outputs, and finally it is saying to https github august demo.git new branch master. So this is my local master and this is my origin master. Okay, branch master set up to track origin master. So the branch master means this is my local master, the master in my local branch. I told you, right? When we do a git in it, there's a by default a master branch with what is getting created, and whatever changes we do initially, that is everything is done on the master branch. Okay, so now whatever I pushed, I did a git push, right? I did a git push minus u origin master. So all those changes have been pushed to the master branch, to the origin master. Origin master means the master of my remote branch. So let's check if it is there or not. Okay, I'll go to your repositories. Here, August demo was my repository. Okay, so I see this. See this. It says file1.txt is present here. Earlier it was not there, right? So I pushed it from here, and now it has come here. And see the branch. The branch is master, and we don't have any other branch now. Only one branch we have it. That is the master. Okay. So we saw that. We also saw that you have versioning two things, like two places you have versioning now. You had your versioning at your local repo level, and you are versioning at this repo level as well. And if you open this file, you will see the changes that we have. Okay, hello from server one, new server. Okay, you can see this. And if I go to the history, so you can see the history here. First commit and the second commit, the two commits that we did. Committed 25 minutes ago, 20 committed 17 minutes ago. So now you can see the versions here, also the commit ID. See the commit ID you can also see. So now I can track the changes at two places. First commit, second commit. I can track it from here as well. Okay, got it? Prakash, got it?
Hello? Yeah, can you hear me?
Yes, I can hear you.
Okay. Yeah, I got it. Yeah.
Got it?
Yes.
Okay.
So
So
even for public, we have to use a password, isn't it? To push.
public repo, you mean?
Yeah. On
Yes, yes,
GitHub.
yes. Yeah, yes, you have to give it because that is unique to it's public, but it is unique to your account, right? That repo
Okay.
is you have created inside your account. So it
Mhm.
needs something to get access to your account. It's not like that anyone it's public, like it's not public as that anyone XYZ person can put
Mhm.
anything in your account. It's public, like
Okay.
it is visible to others. That is why it is public.
Okay.
But to link your local repository to the remote repo, you have to link it. How do you link it? You have to give a username password, right? Username would be your GitHub user, and password will be your personal access token that we just generated.
So that
Okay.
means anybody can pull it, but they can't push, isn't it?
Yes, anyone can pull it. Pushing also they can do. Push also they can do.
But it's asking for password, right? Pushing.
Yeah, if they know this, if they know that password, only then.
Okay.
So we'll see
Yeah,
that.
but they can pull without password, correct?
No, they have to set it up. Like they have to
Yep.
connect it to your remote repo, only then they will do it, right? I'll show you. I'll show you an example.
Okay.
Okay.
Sure.
So this is my laptop one, right? This was my
Mhm.
server one. So I created two servers, right?
Yeah.
Let's go back to my another server. That is my another user.
Mhm.
Okay, I'll create a new session for this guy. I'll just change some settings so that it is more visible. Like you can differentiate. Mm, let me change. Background, let me change it. Mm, Oh, sorry. What was it? 164. Again, I have to change it. But that is fine. I'll not change it. Okay, let's change it. I'm just making sure that it is. You can differentiate between those two users. That's it. Sorry, I'm pretty bad with colors and designings. Okay, white. Cursor text. Cursor text. Cursor color. Again, let's change the cursor text too. You can see it, right? Is it visible? Is it visible,
Yeah,
or
yeah.
should I change more colors? Was it not changing my text color? Okay. I'll change it to black. Yeah, now it is fine, right? So again, this is my second screen. Like, this is my second user. Okay, here also I'll do a sudo su -root. I'll create do that as a root user. Is it a text visible, or let me change? That went bad, I guess. Appearance, change, add Korean only. Okay, now it is fine, right? So I did again as a root user. What I'll do, I'll install Git here as well, because here Git is also not installed. So I'll do yum install Git -y. So in installing Git, so let's check the Git version version. Okay, Git version is 237.1. This is fine. Okay, then I'll do which Git, just to check at which place it was installed. It installed user bin Git. That is fine. And again, configure the things, like the things which I configured there. Git config global version. I'll name it something else this time. Okay, I'll not use my name. I'll use, let's say, John. Okay, and email ID also, I'll use some other email ID. Even if you don't configure this name and things, it will take by default this, your host name. Okay. Okay, so I configured both of the things. So here, what I'll do. So here also I do have to do a git init, right? Because if I do not do git init, Git will not work. I have installed Git, but it will not work. So I'll create a directory here as well. I'll name it mkdir John directory, whatever you want to name it. Okay. I'll do a cd into this. So I'll do a git init. So initialize empty git repository in John dir git. Similar thing that we did here. If I do ls-altr to check the hidden files, it is showing me .git got created. Okay, now this particular directory, John dir, this is also version control now. And here you can run all the git commands, whatever you want. Git status, See, there is nothing on branches. So by default, the branch was master. Everywhere by default, the branch is master only. It says no commit yet. There's nothing here, nothing here. So what I want to do, I want to pull the changes that are that user one had put. Okay. Now user one has pushed the changes to the master, right? On the master, if you see, user one has pushed those changes. Puneet had pushed those changes to this repo. And now my user 2 wants to edit this file again. He wants to make some changes on it. What he will do? He will have to pull it, right? He will have to pull this to his side. Then he will do it, right? So what we'll do here? I will again do this. I'll do a git pull origin master. No, sorry. Before that, I have to define my origin. Before that, also this is a local repo, right? John, I'm in my local repo right now from John directory. Now again, I have to link my this local repository to the remote repo. Correct. Only then I'll be able to bring anything from my remote repo to the local repo, right? So again, I'll do this thing. I'll do git remote add origin. I have to give it a origin, right? I have to create a link between the local and the remote. So again, what was my repo name? If I want to go to the repo, I want to just check what is the name of my repo. Okay, not here. It is giving me a single branch. That is my master. And here it is my. This is the thing I'm interested in. This is how I link my. See. So this also got linked. Okay, John directory also got linked to the remote repo now. So if I do a pull, now all the changes from that repo, from the remote repo will come here. I'll do a git pull origin master. See, it's saying enumerating 6 objects, total 6, untracking. This is whatever from HTTPS this branch master fetch head new branch master origin. So that means it got pulled here. So if I do ls-lstr, so you can see file1.txt here. You saw it? Yeah, Prakash, you were right. Prakash, you were there. You said no, that we don't have that we have to enter the username and password again and again. So for here, we did not have to enter. For pulling, we do not need the username password again and again. Okay, just for pushing, we'll need it, and that too. And before that, we have to just link my local repo to my remote repo. That's it. Got it? So I did a git pull origin master. It pulled all the changes from the remote. Origin master means my remote repo from the remote master to my local master. What is my local master? Means the local, that is the default branch in the John directory that is having. Okay. Now file1.txt has come here. And again, if I want to check the log, git log. So it will show all the changes. It will show all the commits that happened to this file. Okay. Got it?
Yeah.
Got it, Prakash?
Yeah, can you hear me?
So now let's say John has to edit this file now. Okay, John has to edit this file. Now John does a vi. Let's say get status from here. What does it show? Get status. So it says nothing because we have not made any changes. We do not have anything in our untracked and in our working directory and in our staging directory. We don't have anything. So it says nothing. Git status saying nothing. So now let's change something in this file. Okay. pi file 1.txt. I'm adding another line. Okay. Write line from John. I save it. Okay. I do a git status. Git status showing it is changes are not staged for commit, and it says this file has been modified. Now I want to commit it, so I have to move it to staging area. So which command I'll use? Tell me. Git add name of the file. So my file got added to the staging area now. So now again I'll do git status. Now it says changes to be committed. So now it has been added to the staging area. Now the changes are ready to be committed. So now I'll do a commit. Git commit minus file name minus m and the message, commit message. Third commit, I'll say third commit from John. Okay. See, it got committed. Got it. So now I committed it in the local repo of John. So now tell me, will these changes be visible on user one's local repo? Prakash? Tell me.
Can you hear me?
Yeah, I can hear you.
So we did add and when we committed.
I have committed everything in my John's local repo. Okay, so if I go to my Puneet's local repo, that is the another user, will these changes be visible?
No, it's in local repo, right? So it will not get updated to GitHub.
No, I'm not talking GitHub. GitHub I am not pushed. I'm talking about another local repo. I'm talking about this local repo.
John's local repo. Yeah. Okay. No, they're
here
not,
also it will not be updated, right?
Yeah.
Here also, if I see the file, it will still be at the old stage.
Yeah.
See, it is still at the old stage. Hello from server one, new line. It is not having the new line which I just entered because I have committed it in John's local repo.
Yeah.
And same would be in the remote repo. In the remote repo also, there are no changes yet because I have not pushed those changes to the remote repo.
Yeah.
Okay, so what will this guy John do? John will push the changes to the remote repo.
Yeah.
Okay, so what is the command for push? The same command. Push minus git push minus u. Git push minus u origin master. So now for pushing, he needs to provide a username password. Puneet.gavri@gmail.com. So this was my password username for the GitHub account. Okay. And the passcode is this token. Okay. So it says writing objects, counting objects this. So it says it has been pushed. Branch master set up to track origin master. So this means from my local master, now the things have been pushed to origin master. What is my origin master? That is my remote repo here. So if I do refresh it, so here this will have all the changes. See, it is giving third commit from John. And if I open it, see here it says line from John. Okay, if I see the history, it will show you the history. This commit was done from John, and this was the commit ID. Got it? Got it?
Yes.
Okay. Now Now my file1.txt on my remote repo is updated. Now my user Puneet wants to make changes. Like he wants a latest file, right? He wants to make changes on file 1, so he wants the latest copy. So what he'll do? He will pull again.
Yeah.
Okay, git pull origin master. So I'm pulling from origin master. So all the changes that are in the origin master, that is my master of the remote repo, will be pulled to my local master. So see, it is saying one file change, and what was the change here? So my file here should be updated. pi file1.txt. So see, it has a new line from John now.
Okay.
Okay.
Yeah.
So this is what it is.
Yeah.
This concept is clear?
Yes.
Okay. Now let's say I'll show you some other commands. Let's say John, now this Puneet user enters something, changes something in the file. File1.txt. He adds something else. Another line. Okay. So there's a command called diff. I can do a git diff the name of the file. So it will show you what is the difference between the file which has been committed and the file right now. So see, what is the change? This is the same. The only change is plus another file. The file which the line which I added. This is the only change.
Yeah.
Okay. This is one command. Other commands are very easy. Like other commands are like if you want to do there is a command to reset. Okay, there is a command to remove. For example, if you want to remove, like similar to adding, like we can add something in the staging area. Similarly, we can remove that thing from the staging area as well. Okay, let's try that as well. Okay, so I'll do a git status. So it will give me modified this file. Let's add it to the staging area. Okay, I'll add it, git add. So instead of the file name, I'm again doing this, right? Git add file name, git add file name. So instead of doing the file name, let's say I have 10 things in the staging, in this modified section, right? In this modified section right now, I can press dot, git add dot. This means whatever the files are in modified state now, all will move to the staging area.
Okay.
Okay. It is the same. Git add file. If you want to do file one by one, then you can add the file one by one. Git add this file, git add this file, git add this file. Or if you have 10 files, you can just write git add dot. All the files will move to the staging area. Okay, so this is the staging area. So I'll check git status again. Git status. See, it is in staging area. So I can remove from the staging area as well. I can do git remove. Let's say I made up my mind here that okay, I don't want to commit this file. By mistake, I moved this to the staging area. I don't want to commit this file. I want to keep it untracked again. Okay, I again want to move it to the working directory. So I'll do git remove file1.txt. No, not remove. Git reset. Reset is there. Unstage file1.txt. So if I check the file1.txt, let's check the status. So see, it is back to modified now. I moved it to staging area. I did a git reset. And again it moved back to this stage. Okay, so this was the command, and what are the other commands I can show? We'll discuss about the branches. The branches is important. Branches are important. I'll show you the branches maybe in the next session. But yeah, this was the basic. Today we covered all the basics of Git. What are the basics and what are staging areas? what is local repo, what is the remote repo, how to move files from this area to this area. Okay, git add, git reset, git commit message. Okay, how to get git log. Okay, these things we checked. Okay, clear on that? Clear on that?
Yeah.
Okay, so let's continue next Saturday. We'll start with the next Saturday. We'll start with the branches. How can we do the branches? So right now, everything we were doing on the master only, right? Master was the default branch that we're using. Like by default, when we do git init, so by default, everything happens on the master branch only. That is the main branch. So next time when we'll do, we'll try to create branches and play around with it. Okay. So what you can do, you can practice it. You can create a GitHub account, and yeah, you can do what we did today in the class. Like create 2 EC2 instances on one EC2 instance, add some files, and then and from other EC2 instance also add some files, and then try to push it to the master, pull from the master, and those things. Try these commands. Okay. Any questions, Prakash? Shah, any questions?
Hello.
Yeah, I
Can you
have
hear
to go through. I will go through the videos because yeah. Okay. Next week I'll come back to you. Okay,
Go through the video and also try to do the session, like demo, because if you watch this video, it will be like you'll be fine. But if you might face some errors when you are actually doing it. Okay, that's why try doing it. Try doing a demo or practical session. Okay.
All right. Thank you.
Okay, so we stop
Yeah,
the session
thank
now.
you.
Okay,
Yes,
so
thank
let's.
you. Thank you.
Okay, so let's continue like on next Saturday. Okay.
Okay. Bye. Bye.
Okay, thank you. Bye.